بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Our chapter today is about the range of a function which is defined algebraically. Let's begin with some facts about intervals. A and B are two real numbers such that A is smaller than B. The interval AB is the set of all real numbers lying between A and B, including A and B in this case because the interval is closed at A and closed at B. Types of intervals. In fact, there are three types of intervals. We have the open interval, which is given in this form and means that x is between A and B excluding A excluding B. We have the closed interval, which is given in this form and means that x is between A and B including A and including B. And we have the semi-open or semi-closed interval, which is given in one of these two forms and means that x is between A and B, including A excluding B, or x is between A and B, excluding A and including B. Let's do some applications. We need to classify each interval. Now this interval is an open interval, this is a closed interval, and these two intervals are either semi-open or semi-closed. Now try to do this application alone. Now let's continue talking about facts about functions. F is a continuous function which is defined on an interval AB. If f is increasing and x is between A and B, then we can say that f of x is between f of A and f of B. Let's see it graphically. Well, if this is A, this would be f of A, and if this is B, this would be f of B. Now if we choose x between A and B, as you see here, f of x would be between f of A and f of B. Now if f is decreasing and x is between A and B, then we can say that f of x is between f of B and f of A, and in this case we have to flip the boundaries. Let's see it graphically. This is a decreasing function. If this one is A, then this would be f of A, and if this is B, this would be f of B. Now if we choose x between A and B, as you see, x is between A and B, so f of x would be between f of B and f of A. Let's see this application. This is a curve we need to complete by smaller, greater, or equal. F of -3 and f of -2. Now if you see it graphically, f of -3 is somewhere here, whereas f of -2 is somewhere here. So we can say that f of -3 is less than f of -2. And if we want to see it algebraically, you can say that -3 is less than -2 and f is increasing. So f of -3 is less than f of -2. Now let's continue with the second one. We need to compare f of 2 and f of 3. This is 2, this is f of 2, and this is 3. This would be f of 3. So we can see from here that f of 2 is greater than f of 3 graphically. Also algebraically, we can say that 2 is smaller than 3 and f is decreasing, so f of 2 is greater than f of 3. Now finally, we need to compare f of -2 and f of 4. Well, f of -2 is somewhere here, and f of 4 is somewhere there. Now in this case we cannot compare it algebraically because the function is neither increasing nor decreasing, but we can see it graphically. We can see that f of -2 is positive, whereas f of 4 is negative, and a positive is always greater than a negative. Let's continue with the second part. Well, f of x and 0 when x is negative. When x is negative, we can see that f of x is greater than 0 because the curve is above the x-axis, and when x is greater than 1, so from 1 on excluding 1, we can see that the curve is below the x-axis, so f of x is smaller than 0. Now if we need to compare f of -1 and 1, f of negative 1 is 1, so they are equal. Let's also complete, if possible, what is f of 2. When x is 2, we can see that f of 2 is negative 2. And f of 0, we see that f of 0 here does not exist because 0 is not in the domain of definition. Also, f of half, this is half, and we don't have any curve here. Half is not in the domain, so f of half doesn't have an answer. And similarly for f of 1. Remember, when x is 1, we don't have a curve. That's why we put this open circle. Now let's see what is the limit as x tends to 1 plus. When x is at 1 plus, the limit in this case would be negative 1. And the limit as x tends to 0 minus, when x tends to 0 minus, we can see that the curve is upward, so this becomes plus infinity, and when x is plus infinity, the curve is somewhere here, which is negative 3. So pay attention, if we want to find f of 2, this would be a number, whereas the limits could be numbers or infinities. And in case we have an open circle like this one, we cannot find f of 1, but we find the limit as x tends to 1. Okay, now let's see the range of a function algebraically. Let's see this activity. We have to complete the table below by referring to the curves that represent a function f. Now this is a table that should be completed by referring to the following curves. Let's begin. Well, this is curve 1. Sense of variation is strictly increasing, as you see. Domain. The domain of this curve is negative infinity, positive infinity. Its nature, the nature of this domain is open. And the image, or the range, or f of I, the range is from 0 to plus infinity. Remember, to find the range, you project on the y-axis. And its nature is also an open interval. Let's see another curve. This is curve C2. It's also strictly increasing, as you see. Well, its domain is from 0 closed to plus infinity. This is a semi-open or semi-closed interval, and its range is from negative 1 to plus infinity, closed at negative 1, and this is also a semi-open or a semi-closed interval. Let's see a third curve, which is C3. Well, it's also strictly increasing. Its domain is negative infinity, 0 closed. It's semi, and its range is from 1 open to 3 closed. It's also semi. And finally, with the fourth curve, C4, it's also strictly increasing. The domain is 2, 4, which is closed, and the range is negative 1.3, which is also closed. Now let's see the results from this table. This is a table. Now, can we compare the continuity and the sense of variations of f? So in all cases, we can state that f is continuous and is strictly increasing. Now, what can you say about the nature of I and the nature of f of I? If we want to compare the nature of I and the nature of f of I, we can see from here that I and f of I have the same nature. You see? They do have the same nature. So in this case, we have f is continuous and strictly increasing, and I and f of I do have the same nature. Let's continue. We're referring to C4, and this is C4. What relation exists between 2 and negative 1? This is C4. What is the relation between 2 and negative 1? This is 2, this is negative 1. You can see that f of 2 is negative 1. To get this negative 1, we need to apply an f here. Referring also to the same curve, what is the relation between 4 and 0.3? This is 4, this is 0.3. This is 4, and this is 0.3. We can also say that f of 4 is 0.3. So from here we can say that f of 2 is -1, f of 4 is 0.3. We are referring to curve 2, this is curve 2. What relation exists between 0 and -1? This is 0 and this is -1. We can also say that f of 0 is -1. So pay attention please. If we have a strictly increasing function, a continuous function, and in case the interval is closed, to find this answer we can simply apply an f here. Now referring to curve 1, this is curve 1, what relation exists between -infinity and 0? Now here we cannot say that f of -infinity is 0 because the interval is opened, but we can say that the limit of f of x as x tends to -infinity is 0. The limit when x tends to -infinity of f of x is 0. Now let's refer to curve 3. This is curve 3. What relation exists between -infinity and 1? This is -infinity and this is 1. We can also say that we just put a limit, and the limit of f of x as x tends to -infinity is 1. So try to make a certain conclusion from here. Let's see. If a function f is continuous and strictly increasing, then first we can say that its domain and range have the same nature. If one of them is open, the other one would be open, and closed would give a closed interval, and semi would give a semi-interval. And in this case, if I, let's say, is the closed interval AB, f of I would be f of A, f of B. So in case we have a closed boundary, we just put an f here, whereas if we have an open boundary, we have to apply a limit. So closed, we apply an f, and opened, we apply a limit. Thank you.